Hello everybody, it's Jack. I'll be talking about Chapter 5, Section 1, finding critical points such as the maximum and minimum. Some main ideas in Chapter 5, Section 1 is what is a critical point? Well, a critical point is when slope is 0. As we can see in these two graphs right here, these slopes are both 0. A critical point can either be a minimum or it can be a maximum. Now, what is a maximum and what is a minimum? Maximum is the highest point in the graph, a minimum is the lowest point in a graph. What is an absolute maximum and minimum? An absolute maximum and minimum are the absolute highest and absolute lowest points in the graph. So in this graph, letter E is the absolute minimum and letter F is the absolute maximum. What is a relative maximum and minimum? Relative maximum and minimum are as well max and mins in a graph, but not as low or as high as the absolutes. In this graph, letter A and letter C are both the relative minimums. Letter B and letter D are both the relative maximums. In Chapter 5, Section 1, an important equation or rule is the first derivative test. The first derivative test is a way of checking whether a critical point is a maximum or minimum. In this example here, find the critical point of Q of t, which equals 526t minus 36t squared. First of all, Q prime t, which equals 526 minus 72t, and set it to 0. I got this by taking the derivative of this first equation and placed it here. So you solve for 0. You minus 526 from the left and minus it from the right. And then you get negative 72t, which equals negative 526. Next, you would divide by negative 72 from both sides, and you will get t, which would equal 7.31. And that right there is your critical point, which is a maximum. Here's another example of using the first derivative test. But at the end, we're going to find critical points as well. So in this example, f of x, which equals x squared minus 2x with a domain of 0, 4. F prime of x, which equals 2x minus 2, is the derivative of this first function. So you got 2x minus 2, which equals 0. Add 2 to both sides, you get 2x, which equals 2. You get x equals 1. Finding the critical points, you have two options. This first option, you use 2 points of the domain, which will be 0, 4. As well as the x value, which will be 1. Next, you use the first function of f of x, so that will be x squared minus 2x. And you plug in the 3 points in the function. So right here, you have f of 0, which equals 0 squared minus 2 times 0, which is 0. Then you have f of 1, which is 1 squared minus 2 times 1, which equals to 1 minus 2, which turns out to negative 1. And then you have f of 4, which equals 4 squared minus 2 times 4, which equals 16 minus 8, which is 8. And now you have your 3 points, or your 3 critical points. Here's the same equation with the graph drawn out. Keep in mind, critical point was 1, 0. So option 2 of finding other critical points, you're going to set up a horizontal chart like this. You're going to determine points next to the critical point. So our critical point was 1, 0. A point to the left will be 0.5, comma 0, and will be on the right will be 2, comma 0. So up here we have our x values. We have our 0.5, our 1, and our 2. Next, you're going to plug in our chosen x values into our f prime fx function. So our f prime of x function was 2x minus 2. We plug in 0.5 in this equation and you get negative 1. You plug in 1 in this equation and you get 0. You plug in 2 into the equation and you get 2. Next, you're going to determine if the graph is having a downward, constant, or upward slope. So our next graph aisle will be the direction. In the graph you can see it is going downwards as it is right here. When you get to 1, 0, it is a constant, and then when you get to 2, 2, the graph is increasing. And that there wraps it up for Chapter 5, Section 1, finding critical points, maximum and minimums. Thank you again for watching. I hope you enjoyed it and hope you learned a little bit, and good luck on your final.